London is in Africa. So we are asked to find whether or not the conclusion necessarily follows the premises. If you look at what we have here, let's say L is for the London, then N is for the Nigerian, or let's say A is for the African. If you have, because I made it clear that Venn diagram is very necessary in logical reasoning. We have London. We have London here. Let's say it's a capital, London. And we have the Nigeria here. We have Nigeria here, and we have Africa. This is, let's say this is Africa. The argument, London is in Nigeria, which is justified by the Venn diagram. This Venn diagram. Nigeria is in Africa. Automatically, Nigeria is in Africa. Then therefore, London is in Africa. London is a subset of Nigeria. Nigeria is a subset of Africa. Therefore, London is a subset of Africa. Here, the statement, the argument here is valid. The argument here is valid since London is in Nigeria and Nigeria is in Africa. The argument here is valid that London is in Africa. But we all know that London is never in Nigeria. So what we can deduce from here is that the argument is valid, but the conclusion is not true or is untrue, since we know that London is never in Nigeria. And since London is never in Nigeria, then London can never be a subset of Africa. Though the argument that London is in Nigeria is valid, since if London happened to be a capital city in Nigeria, automatically it will be a subset of Nigeria. And since Nigeria is a subset of Africa, so automatically London is supposed to be a subset of Africa. So that means the argument is valid, but the conclusion is not true, simply because London is not in Nigeria. Question number 4, which is the last for this exercise. In the following arguments, determine whether or not the conclusion necessarily follows from the given premises. All drivers are careful. First premise. Careful people are patient. Second premise. Then therefore all drivers are patient. This question, from the way it is designed, it is obvious that it is a chain rule. And since it is obvious that it's a chain rule, in the first premise we have all drivers are careful. All drivers are careful. First premise. Then the second premise, careful people are patient. This is the second premise. Then, therefore, all drivers are patient. Why I call this a chain rule is because the first premise link the second premise, and the second premise link the conclusion. So automatically, D, let the first premise be D. Let the first premise be D. First premise, let it be D. And the second premise, let it be P. No, let it be, yes, P. Or let it be C. Let the second premise be C. Then, all drivers are patient. Let it be, that's the conclusion now. Let the conclusion be D. Be peace, rather. So here, we have D implies C. All drivers are careful. Careful people are patient. So D implies C. Come on. Then we have C. Careful people are patient. All drivers are patient. So C implies P. It follows from the conclusion that since D implies C and C implies P, then it follows from the conclusion that D will definitely implies P. And since this is connecting this and this is connecting this, and therefore this is now connecting this, we call this a chain rule. Linear inequalities. Linear inequalities in one variable. We expatiate or we try to analyze linear inequalities by the use of notable symbols. The linear inequalities in one variable, it follows representation on a number line where we have these for less than, we have these for greater than, we have these for greater than, or equal to. We have these for less than, or equal to. Then we have these which is equal to. Then we have these not equal to. Not equal to. These are notable symbols that are on display as far as linear inequalities is concerned. Let's look at some scenarios to justify our claim. If there are 40 people, then X is equal to 40. This is an equation. If there are less than 30 people in the bus, then X is less than 30. That is an inequality with the inequality symbol less than. Example 1. Find the range of values of X for which this 5X minus 4 greater than 11. Show the result on a number line. So here we have 5X minus 4 greater than 11. So we collect like terms. So by collecting like terms from here, we have 5X greater than 11 plus 4. And then we have 5X greater than 15. So we divide both sides by 5. By dividing both sides by 5, we have our X greater than 3. So if you are to showcase this on the number line, this is a number line where, let's say this is your 0. Then we have our, let's say 3 here. So this will be x greater than 3 on a number line. That is how to show that show our result on a number line. Example 2. Solve the inequality -2 into 13 plus x greater than 9 plus 5x. Here, what we have to do first is to expand what we have here. By expanding this, -2 times 13, that gives us -26, minus 2x is greater than 9 plus 5x. Then the next thing we do is to collect like terms. Collect like terms, bring this onto this side, I will transfer this onto the other side. We have -2x minus 5x greater than 9 plus 26. Then -2x minus 5x will definitely give us -7x. This plus this, that gives us 35. So we are interested in calculating our x. It should be noted that when dividing an inequality sign by a negative number, the inequality symbol reverses. So if you have it in a greater than case, it becomes less than. And if you have it in a less than case, it becomes greater than. So in that situation, divide both sides. Divide both sides by -7. Divide both sides by